I think we're good. All right, so I guess we can start with our preparation, and if you had any questions.
I didn't have any questions, but I did something different this time.
Okay.
So, like while I was doing the preparation part, you know how on our tests we can have the one sheet of notes? I wrote my notes, and then I tried to do my homework only using that sheet of notes.
And how did it go?
So kind of like the test would be. So I'm like, okay, I need to write that down because I don't know it. You know, and so I found that actually helped. And then I like took my homework quiz only using those little bit of notes from that lesson, and I did it just from my notes. So like I'm confident that the notes I've taken will be good enough.
Beneficial. That's awesome.
Yeah,
that is a great idea.
I haven't taken the homework quiz yet.
Me neither.
Oh, good. Okay.
Jennifer's just on top of the game. She's like, these notes are so good. I love this strategy so much. I'm just going to take all these quizzes. I might as well jump to lesson 11. Let's do this.
There you go. Yeah, I'm going to do that.
That's a really good idea. I like that idea.
Yeah. I did think that I needed to start writing my notes this week while all of this is still fresh, instead of trying to go back and think, oh, what is it that I need to remember? I just think that I have a hard time remembering the terms, and that many of the terms mean the same. I mean, the things that we were looking for 2 lessons ago are the same things we're doing now. It's just a different term.
Right.
Or at least it seems like that. I don't know. Yeah. I mean, none of it seems hard. It just seems like there's a lot to remember, but none of it.
Yeah.
Yeah.
Sure. Well, just like what lesson was it when it says something, put this in English? It's like a foreign language. So if you see it often enough or write it often enough, you'll learn it eventually. So
yeah. So
it's so funny. I've been
problems or issues that we need to go over with the prep?
I don't think I have any questions on it.
No, I think I understood it all right.
Okay. I'm gonna plug in my other screen here. Then do we want to go ahead and just get started on the quiz?
Sure.
Okay. I feel like it takes me forever to open them up.
Me too.
All right, I'm ready. Everybody else is ready, finally?
I'm gonna grab my calculator.
I'm getting there.
Yes, I'm ready too.
My calculator up.
All right, are we all on question 3?
Yes.
Yep.
Okay, it says find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25. All right. Anyone else get 16.45?
Yeah, that's what I have.
That's what I got.
Okay, 16.45. The next one is which of the following statements is true? Okay, I do not know how to read all these symbols. So I'm just gonna, is that a standard deviation squared?
Yeah.
Okay, is an interval estimator of x bar. X bar is a point estimator of, that's mu, right? Is that how you say that?
Yeah.
Which is the mean.
Population mean.
Population mean. Population mean is a point estimator of x bar. Standard deviation is an interval estimator of standard deviation squared.
I think it's
B.
That's a B. That's what I think.
I say B.
That's what I think too. All right.
X bar is a point estimator.
I think in my notes, I think I wrote that.
Oh, yep. I have that right in my notes right here. X bar estimates mu, or estimates, X bar estimates population mean.
Yeah.
Yep. I think that's right. Okay. Next one is Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of size n equals 64 and computes x equals 526. Use this information for the next 6 questions. Okay. So this first one is, what is the point estimate for the true GMAT score? I think point estimate is just another, well, is that the margin of error?
Well, 526.
526 is the.
Yep.
point estimate for the GMAT score. Yeah, they're asking for the population mean.
Yeah.
Right?
Yeah.
Yeah.
Yes, I think they are asking for the. Well, I think they're asking, isn't it the sample mean?
The sample mean is X bar.
Is X bar.
Perfect. So it's 526 then?
Yeah, they're wanting the true GMAT score, which would be the population mean, right?
It's kind of just like the question you just answered.
Say that again?
It's kind of like the question we just answered, how X bar is a point estimator of the population mean, right? So yeah, that's what they're asking for.
Okay, so 526 then?
Yes.
Okay. What is the margin of error for the 95% confidence interval?
I got 27.685.
That's what I got. Well, for the upper. Oh, yeah, 27.685, yeah.
Sorry, I'm just writing it down. Give me 1 second to just. What did you say you guys got?
27.685.
Perfect.
That's what I got too.
All right. 27.685. Okay, the next question is, what is the lower limit of the confidence interval?
So I have 498.315.
Wow, you guys are down into this.
That's what I got.
And I'm drawing a blank as to how we do that. Come back here.
So you just are going to subtract that 27.685 from 526, from the mean. And that gives you the lower limit.
Oh, okay, that's right.
So it's like it's 526 plus or minus 27.685, right?
Right.
Okay, that's right.
Okay, so we're looking for the lower limit. So
right.
So 498.315?
That's what I got.
Okay, so you said subtract the 27.685
Yes.
from the 526?
Yes.
Mm-hmm.
Okay, so 498.3. Okay.
So another, and I liked in the prep assignment how it gives you kind of that long equation for the lower limit and the upper limit. But then another way to write it I really liked was x bar plus or minus m, which is the margin of error, which I think kind of helps. That helped me a little bit just to see, okay, so we already have the margin of error. Now I just have to take x bar and plus or minus for the lower and upper limits. I kind of like that equation because it kind of made it a little more simple. Yeah. Now they're asking for, it looks like the upper limit. $553.685.
Yep, that's what I got.
Yeah.
Yes.
Okay. What would happen to the width of the confidence interval if Gina increased the sample size?
I always have to think about this.
I have it written on my notes.
Do you?
I have that it will decrease.
Yeah.
I also have that in my notes, that if the sample size increases, the width of the interval decreases.
Because it becomes more focused, right?
Right.
Okay.
Yes, exactly. I also have in my notes, if you guys want to jot it down, that because I'm sure it will be a question at some point, is that if the level of confidence increases, the width also increases of the confidence interval.
Yeah, I put that in mine too.
So that's the next question, actually.
Oh, is it?
Oh, is it?
Yeah.
Oh, perfect. What would happen to the width of the confidence interval if Gina changed it to 99? So it will increase then, according to my notes. And again, I think it's because it's just more focused. You're becoming more accurate, so at that point you go from being 95% sure that it's between these two numbers to now I'm 99% sure it's between these numbers. So the width is just going to get Well, no, because the width gets bigger, right? The width increases.
You're increasing your ability to catch the number.
Yeah. Are we all on number 11?
Yep.
Yeah.
Okay, it says Bright Bulb Light Bulb Company is planning. Bright Bulb Light Bulb Company. Say that 10 times fast, guys. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need?
I always have to think here, oh, how do I do this? Confidence level is 0.960 times.
I got 16.
Okay. Hang on, you're ahead of me. I'm still trying to remember. So times the standard deviation divided by the number of hours.
Okay, what did you say you got, Jen?
I got 16.
Okay.
Did you remember to square it?
No, I always forget that. Thank you. Okay, now I got 246. I forget it every time.
1 point.
Yeah, I do too. I have to make sure I write it down. I'm writing it on my paper or I always forget.
Yeah. Square, square, square.
So Jeannie, did you find the formula for that?
Yeah, yeah, so it's just 1.960 times 400 divided by the square root of 50 squared.
No. No.
No?
It's 1.96 times 400 divided by 50. And then you get an answer, and then you square the answer.
Yeah.
Okay. Oh, I'm doing it for the sample size. Isn't that what you do to get the sample size?
No.
To figure out what size of a sample you need?
No, the equation for the sample size is...
Oh, not the square root, not the square root.
Nope.
Okay, let me, 1.960.
Did you guys get 246?
Yes.
Yeah.
I sat there for like 3 minutes. I could not think of how to come up with the margin of error, and it says it right in the question.
246.
It says it in the question. Oh, it's the margin of error, yeah.
Yeah, I'm trying to solve for the margin of error, and I'm like, I can't, this isn't working. And then I was like, oh, it's way more simple than I forgot how it just gives you that one. Perfect.
Okay.
So, Jeannie, did you find the formula?
Yeah.
They actually,
yeah.
Okay.
It's, yeah. I was doing it I mean, I have it written down, z times the standard deviation divided by the margin squared, but I was doing it the square root of the margin.
Okay.
Which up to this point, we've basically square rooted that every single time. So I totally get that.
Yeah.
All right. Are we all good on 12?
Yeah.
Okay. The mean salary of actuaries is $100,000, and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of significance of x equals 0. Or no, that's the alpha, right? Equals 0.05. You collect a simple random sample of n equals 36 and find that x bar equals 111,000. Use this information for the next 3 questions. What is the lower limit of this 95% confidence interval? Okay.
So I got 99,001.53.
I got 88,001.53.
Well, we have to round to the nearest whole number, so I got 99,002.
99,002, yeah.
Okay, so what did you guys get for your
Margin of error?
11,398.47.
11,098.
998.
998.
That's your margin of error?
Yes.
Do you guys all get that same margin of error?
That's what I got. 11,998.66.
Okay. I must have been a little math thing.
I got 0.47.
6.467, yeah.
Let me look again. 1.9.
How did I get? And then you subtract that from
the
111,000. From the 11?
111,000, because that's your mean.
Your sample mean.
I was subtracting it from the population.
100.
So we subtract it from the sample mean, not the population mean?
I think so.
So you guys, let's see.
Okay, go
subtract it from your X bar.
So, I'm sorry, what?
I think you would subtract it from X bar, so you take 111,000.
Yeah. Okay, let me try that.
Plus or minus 11,998.467.
Okay, so then I got 99,002. Yeah, 99,002, which is what you guys got, right?
Yeah. I got, 99,002.
Okay, they want us to round to the nearest whole number. Okay. Perfect.
And then I get, for the next one, 122,999.
I got 112,198. How did I get that? That can't be right.
Well, you need to add that 11,998 to 111,000. So did you just add it to the 99?
Maybe. So you get 122,998.
999.
9 or 8?
I think it would be 998.
It says round to the nearest whole dollar. I guess it's 46 cents, but yeah, 998.
Okay.
So I think in this case it would round. I think it would round down to 998.
Yeah, it says nearest whole dollar.
When you're solving for like the sample size and stuff, you always round up no matter what. Okay, question 14 is there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: a simple random sample was drawn from the population, standard deviation is known, X bar is normally distributed, and all of the above.
I think I wrote that 4 times yesterday, so it's all of the above.
Yep.
We got them all right because I turned it in.
Okay, all right.
Perfect.
What did I do? I missed half of one.
Uh-oh.
On number 7 and number 8. I must have not rounded properly.
What did you put?
What did you get?
Oh no, I got half of half. Oh, I'm like, I'm like, wait, how did I only get half a point? But they were only worth half a point.
Okay.
No.
It always freaks me out when I see that too. I'm like, oh,
Yeah.
Okay. All right. So I will stop the broadcast. Okay. So I like your idea, Jen. I think I'm going to do that. I'm going to start my new sheet of notes.
yeah.
Did you guys have my notes? I had my sheet of paper and I had like the tiniest writing because I was so afraid I wasn't going to be able to fit everything on. And then I had this big blank at the bottom, like, oh, I could have fit so much more.
Like this is how I did it.
Oh, wow.
Like each chapter has its own box because I folded my paper. So that's how tiny I write. So like that's what I wrote for that chapter.
Ah.
Right there.
Yeah.
And like I took that whole quiz and just looked at that. That's it.
Good for you.
And like I didn't have on there that X bar is a point estimator of the population mean. So I wrote that down because it could show up on a test and
Yep.
yeah.
All right. Well, I guess we'll see you Thursday.
Sounds
Yeah,
good.
see you.
Good.
Thanks, Jeannie.
Yeah, bye-bye.
See you guys.
Bye.